Okay. We'd like to get started. First, just some updates. Next week is the second best highlight of the year in terms of grand rounds. Today is the highlight of the year. The Lustman Awards for me are literally tied with graduation, right? It's like, which of your children do you love best? I love them both equally, if you're wondering. But the Lustman Awards are unquestionably just an incredibly special day. We learn every year we're reminded what a remarkably talented group of young people we have, and what an incredible array of opportunities that our department affords our young people to learn. And I want to thank all of the people in the audience who are here today who have given of their time to mentor in one way or another the Lustman Award winners, but also the other people who have had experiences in academic projects or activities. Mentorship is the fuel that drives our department, and the energy, excitement, and curiosity of our trainees meets with this kind of generosity of spirit and shared willingness to engage in a shared intellectual endeavor, and that just fuels our department. And so the Lustman Awards are just a wonderful example of the vitality of our department and the strength of our community. I want to thank everybody involved in that. Again, next week is the State of the Department address. And I do want to share one piece of news which many of you may have heard. Some of you may have addressed as an issue that some of you may have been concerned about. And that has to do with a system that our fearless leader, Francis Collins, was going to introduce, something called a 21-point system that was going to limit the ability of faculty to write RON grants. He had a period in which he solicited open comment, and I think he got more comment than he expected. I gave him my little piece of my mind as well. And he took it back. He's not going to do the 21-point system. He's going to find another way to achieve the ends that he was trying to achieve, which everybody agreed were a good idea, which is to try to make grants more available, particularly to people in early phases of their careers, at the beginning of their career, or getting the first R01s. We sometimes call that the K to R transition. But I think many of us are relieved that he's not going to go with the three grant limit, because I think many of us felt that it was going to stifle collaboration. And collaboration is such a critical part to building vital academic communities that I was very troubled to see that proposed. So I think that's a piece of good news. So congratulations to our recipients, and let's get on to one of the best days of our year.
Thank you all for coming. We have a busy and interesting morning ahead, and I'll try and keep my remarks brief. Today, first and foremost, is a celebration. Of course, it's a celebration of the three awardees today, whose work you'll hear about, whose remarkable work you'll hear about shortly. It's also, as John said, a celebration of our departmental community and all the people involved. Well, actually, within the department, families who've made this work possible. Through their individual efforts, mentors who deserve to be congratulated as well. And of course, finally and most importantly, it's a celebration of the remarkable life and enormous achievements of the individual for whom this award is named. Seymour Lustman served our country as a member of the armed services, as part of the Army in World War II. Afterwards, he pursued a PhD in psychology at the University of Chicago, and then went on to get his MD from the University of Illinois. He developed there an interest in the physiology and the behavior of newborn infants, and in particular was interested and fascinated by the nature and the roles of nature and nurture, what we would call genes, environment, and their interactions today. It was a lifelong interest of his that he brought with him to Yale in 1955 when he started first a residency in adult psychiatry and then went on to pursue child fellowship training here as well. He joined the faculty in 1962 and quite remarkably, 2 years later was, I guess, promoted to the rank of full professor. An unbelievable ascendancy, really amazing. Among his numerous academic contributions, he, along with another group of scholars, including Albert Solnit, Anna Freud, and Joel Goldstein, authored what was considered a landmark text at the time in terms of child maltreatment, Beyond the Best Interests of the Child. I'm delighted to say that this celebration today is now in its 45th year. At the risk of disclosing my own longevity here, that's 5 years longer than the recent Star Wars anniversary. And since 1973, it's remarkable. There have been over 100 Lustman awardees whose names appear on the plaque. Our own Jedi Knights, as it were, who have engaged in a celestial battle against serious mental illness. They are deans, they are associate deans, they are chairs of departments, they are chief medical officers, they are institution chiefs. They're people who have made breakthroughs in our understanding and discoveries that have led to better treatments for individuals with psychiatric disorders. It's a truly distinguished group, and I think today's 3 awardees add to this group in a wonderful way. Finally, I just want to say that this, what has become a wonderful departmental tradition, would not be possible without the generosity, the enormous generosity and the personal commitment of members of the Lustman family, including Susan Katz, his daughter, and her husband John, his granddaughter Emily, his son Jeff and his wife Diane Saslow, and members of the Lustman Family Foundation Board. I hope that you'll take a moment here to welcome those individuals, including Susan, Emily, and John, who are joining us today, and thank them for their commitment to this wonderful tradition in our department. So to get the show on the road, I'd like to introduce Alan Antichevich, who will introduce our first place award winner. He can have the podium and the lightsaber.
All right, no Star Wars metaphors or analogies, but so it's really a distinct pleasure to introduce Young-Sun today. So Dr. Young-Sun Cho received her PhD, MD PhD from University of Rochester, and then joined our department a few years ago as a resident, and has really been on a remarkable tear for a few years now, taking fairly unique and complicated cognitive neuroscience framework that goes after the interaction between affective deficits that we see in severe mental illness and cognitive deficits that we see in severe mental illness. So it's been a remarkable pleasure working with her. Her productivity has been outstanding, with several papers out and several more under review. She's been the recipient of the NARSAD Young Investigator Award while a resident, and the Dietrich Award, which is another remarkable achievement in our department, and finally now the Seymour L. Lustman Award. And so I'm really delighted to have the opportunity to introduce her, but perhaps most importantly, I want to say that Young-Sun is a compassionate and talented clinician, and also a really wonderful person who's been an amazing addition to our lab and our departments. And so for those who know her, she is simply a delight to work with, and we are lucky to have her. So.
Thank you for having me here today, and thank you to the Lustman family for presenting this opportunity to me. The title of the talk is Effects of Reward on Spatial Working Memory, as Alan alluded to. Throughout the talk, I am talking about two major domains, which would be cognition and motivation. And cognition we can think about as processes such as supporting thinking, organizing, learning, and memory, and motivation as the push that allows us to organize our drive and our desires and efforts towards goal-directed behaviors. And both of these domains are disrupted in a number of psychiatric illnesses, which I know everyone in this audience is well aware of, including schizophrenia, substance abuse, and depression. And I just put these examples here as illustrations, but there are certainly more examples within our field. And so we often think about these two domains and deficits associated with these two domains as separate. But we have very limited treatments for each of these. And if we take the example of schizophrenia, for instance, motivation, as it falls under the umbrella of negative symptoms, and cognition, as it falls under its own domain of cognitive symptoms, deficits in these domains actually are related to level of functioning. So more severe symptoms actually lead to worse functioning. But our treatments are limited, and we have very few specific treatments for these symptoms across all illnesses. So our understanding as well is also limited, and what we hope to understand a little bit better here is really the interaction between motivation and cognition, and as it plays out across different psychiatric illnesses, and here in schizophrenia in particular. So of the cognitive processes we're interested in, we're particularly interested in the process of working memory and motivation as it relates to rewards. So our overarching question is, how do rewards influence spatial working memory? And in this talk, I'll go over a task development that I've been working on for the last few years, behavioral results in patients with schizophrenia and healthy control subjects using this task, as well as our recent translation to the fMRI scanner with a group of healthy adult subjects. So how do we define working memory? Working memory can be defined as a temporary maintenance and manipulation of information that's required for cognitive tasks and higher order cognition. And I think the key words here are temporary maintenance. So this is distinct from short-term memory, where in a month from now you may neither remember anything in your short-term memory or in your working memory, but the difference is in the working memory you have to actively maintain this information while you need it. So an example of this would be if someone gives you their phone number and you have to keep it in mind before you can get to a piece of paper and a pen. Another example would be when you're driving and you need directions and someone tells you to take a left and two rights. You have to keep that in mind as well. And the specific type of working memory we're interested in is spatial working memory. There's a few reasons for this. One of the most salient reasons for our lab is that there's a long history of building on spatial working memory tasks from monkey literature that allow for an understanding at the single neuron level. So the basis of our task moving forward is a spatial working memory task. And I'll walk you through this. So it starts with a fixation, and the subject is required to centrally fixate in the central circle. And then a circle appears, a colored circle. In this case, it's red, anywhere on the screen. When it disappears, it is the subject's job to therefore maintain where they thought they saw this circle to be. They have a joystick in their hand, and they will move the gray circle under the probe face to where they thought they remembered that initial circle to be. And the measure that we're interested in is where they move that probe compared to where that initial cue was placed. And so the larger the distance between these two, the worse the performance. The closer the distance, the better the performance. It's a very simple measure, but it's been used for many years. Our twist is to integrate a reward cue in here and to really see how involving rewards and affective components affect cognition. And as we all know in the real world, typically our cognition happens in the backdrop of emotional events as well. So we'd like to start modeling this in the lab. So in some of these trials, subjects will see green circles, which means that there's a possibility to win reward if they do well enough on these spatial working memory trials. When they see this task on the behavioral version, they get a run of neutral working memory trials that are sorted behind the scenes for individual calibration, and so that they're set for individual thresholds for rewards. So the better you do compared to your original performance, the more rewards you get. It's followed by a set of blocks containing neutral trials and trials in which you could win money if you do well enough, as well as motor control trials just to control for basic deficits in being able to move the joystick accurately. We also had a in which we called a context reward presentation, and in this presentation we were really interested in the strength of reward representation, so how people keep in mind rewards over longer periods of time. And so in these blocks, instead of cueing the reward at the start of each trial, they're cued at the start of a block of working memory trials and have to maintain that it's a rewarded context. And this is one of our key manipulations between the trial rewards and the context rewards over a longer period of task execution. We ran this in a group of patients with schizophrenia, adults, and healthy control subjects, matched for age and sex. And what we found, just looking at baseline spatial working memory performance, as well as motor performance, meaning their ability to actually just move the joystick to where a target is presented on screen without any working memory requirements, were both decreased in patients with schizophrenia. And here in the graph on the y-axis is the distance, so the larger the distance, the worse the performance. And in orange is the patients with schizophrenia. This is a well-known deficit, so it was nice to see this replicated in our sample as well. In response to the cued rewards, both groups actually improved performance. So on the left side is performance in neutral trials, just baseline working memory trials, and on the right side is performance on those trials in which they could win money. And there was a main effect of trial type, but both groups performed similarly. This is a scatter plot just illustrating the same thing in a distribution as if all those circles were presented at 415 and 0. And you can see when the trial rewards are presented, the distribution tightens significantly. When we look at the context manipulation, we see that patients with schizophrenia actually show limited and actually no improvement in working memory to contextually presented rewards over a longer block. So this is over 20 trials in which they'd have to perform working memory trials with an effect size of basically 0 and a relatively modest effect size in healthy control subjects. Again, these are similar scatter plots showing the tightening of the distribution across the different trial types. And you can see as you go from the working memory trials to the context reward to the trial reward, the distribution significantly tightens. We also wanted to see what was contributing to the ability to improve working memory. And so what we found was when we correlated baseline working memory performance with % improvement in working memory, we found that it was significantly correlated for both groups, suggesting that the baseline working memory or cognitive ability really influences the ability to be motivated by these rewards and therefore increase your working memory in response to these rewards. So in conclusion, for part 1, in our behavioral task, we found that patients with schizophrenia can actually improve spatial working memory performance in response to cued rewards, but not in response to rewards that are presented over a longer period of time, requiring longer periods of task execution. Baseline spatial working memory performance appeared to be positively correlated with % improvement in working memory in these cued trials, suggesting that the more you have to work with, the better you can improve. And there was no correlation between the rewarded spatial working memory position or any of the clinical measures that we measured. So next we wanted to translate this task to the scanner. And so we ended up making a few tweaks, which I'll go over, and then running it in a group of healthy control subjects. So to do this, we made it an incentivized spatial working memory task, which just means that we added a loss condition. So in addition to having a reward condition, there was a potential to lose money if you did poorly. We tested this task in 33 healthy young adults and used up-to-date fMRI methodology consistent with Human Connectome Project protocols. So the task is essentially the same as what you saw, except for now there's also a loss condition. So now in this version, red means you could lose money, and yellow is now the neutral cue where there's nothing at stake. Again, the task opens with blocks of motor preparation trials in order to gauge baseline motor performance, as well as to serve as a control for baseline working memory trials. So these are trials where there's no working memory really required. The calibration, again, is sorted behind the scenes so that the thresholds for receiving rewards are individually calibrated, which is obviously very important for patients. So task difficulty is standardized across both groups. And this serves as the baseline spatial working memory performance that we compare moving forward, followed by trials of rewarded working memory trials and trials of loss working memory trials, as well as just a few which we call catch neutral trials that are mixed in. We also were interested still in context manipulation, so incentives over a longer period of trial execution or task execution, and these blocks were counterbalanced across the task. I'm just going to go over the trial loss conditions here, as that's what we have analyzed. We haven't looked at the context blocks yet. But we were happy to see that in a group of healthy adult subjects, we were able to replicate the improvement in spatial working memory in response to rewards, and here also to potential for loss or loss avoidance. And this suggests just a salience of the incentive cues. This is the similar scatter plots as shown earlier, showing again the tightening of the distribution under the trial reward and trial loss conditions. And so now we move on to the fMRI imaging results for these same conditions. So our question is really, how does the bold signal really change compared to baseline spatial working memory performance, trials in which you could be rewarded for your spatial working memory performance, and trials in which you could lose money for your spatial working memory performance? And we specifically looked at two phases of the trial, which is encoding, which is that moment when you see that initial circle that you have to remember, and also the delay period, which is the offset, or when that circle disappears. It's that delay period that has garnered a lot of interest based on the monkey work of Patricia Goldman-Rakish and others, where neurons continue to fire even when there's nothing shown on the screen, suggesting that your active maintenance of holding this representation in mind is requiring a lot of neuronal effort. And so we're particularly interested in these two phases. And here we can have it up as a fully factorial 3x2 ANOVA. So this is, I'm going to just show some brain maps, so I just wanted to orient everybody. On the left is the cortical surface, and it's been inflated, which is why it looks a little strange, but this is really to just look into the sulci a little bit better. And on the right is the subcortical view, cut axially. So the first analysis we did is a 3x2 ANOVA, looking at the interaction between the trial types, which is the neutral working memory, the loss, and the reward, versus the different phases. So this would be the encoding phase and the delay phase. You see widespread activation in prefrontal and motor areas, as well as visual cortices in the cortical view, and subcortically within the striatum and thalamus and cerebellum. Our next job is to therefore break down this interaction and see what is driving the interaction. We look at the main effective incentive, so looking to see how the bold signal varies across the different trial types, irrespective of whether we're in an encoding phase or a delay phase. And you can see prefrontal regions that seem to be involved in distinguishing these types of incentives, motor regions and parietal regions, as well as occipital regions, and not much subcortically except for the cerebellum. When we look at the main effect of trial phase, which is the effect of delay compared to the effect of encoding, in orange is the areas in which there is greater bold activation during the delay period, so when that cue is no longer there and you're actively having to maintain it, compared to the encoding phase. And in blue is the areas that are activated significantly to the encoding phase when you actually first see that circle on board compared to when that circle is not there. And what you see is when you see the circle, areas that are activated as would be expected are primarily sensory areas, visual cortices and lateral temporal cortices. And primarily in the delay period when people have to keep in mind these representations, prefrontal regions as well as motor regions, which fit nicely with previous literature. Subcortically, there's a wide array that's elicited by the encoding phase, and in the delay phase, which is represented in the orange, really just in the putamen, possibly for motor preparation or motor representation. That's sort of a hypothesis. When we start to break apart the individual contrasts and we look at the effect of reward encoding, so specifically when you see the reward cue versus when you just see a neutral cue, and these are areas in which there was also a significant interaction and thresholded at a Z of 3. You see mostly in the cortical surface, you see visual cortices, and on subcortically, you see midline thalamus as well as striatal regions, including the ventral striatum. So areas that are involved in reward processing in this case, which fits well with the idea of encoding a reward cue. Examining the loss encoding phase, for the same type of analysis where we look at areas in which there is more activation during seeing the loss cue versus seeing a neutral cue, also attached to a working memory trial. We see significant more activation in motor cortices as well as in the precuneus area, as well as, interestingly, not much subcortically, but it's very hard to see in this map, but in an area called the BNST, which is responsible for vigilance and preparation. When we look at the delay period, which is again the period in which there's no target presented, in which you are actively having to remember things and keep things in mind, there's an interesting pattern in which you don't see much red, which would be the activation, the significant activation of the reward compared to the neutral. But what stands out is actually the blue regions, suggesting that there's relatively decreased activation in the reward condition compared to the neutral condition. And you see this in lateral parietal areas, lateral temporal areas, dorsolateral, dorsomedial prefrontal cortices, and areas of the precuneus. This is a very similar map to the next map I'll show you, which is going to be loss delay versus neutral delay. And it looks very similar. Again, in the delay period where there's nothing that you see on screen and everything is actively maintained and remembered in your mind. Again, very similar regions. And interestingly, these regions are typically regions that are associated with what's known as the default mode network. And the default mode network is a network that has been characterized when people are just resting quietly and have nothing required of them. And there are areas that have significantly correlated activity. And it has been shown that when tasks are engaged, there's relative suppression of this area. And what we're showing here is that in comparison, there's two tasks going on here. So we're not actually comparing to rest. We're actually comparing two tasks that maybe one of which may be more salient than the other, which may be the conditions in which there are incentives, losses, or rewards, also showing a relative suppression of these default mode areas in relation to neutral working memory trials. So in conclusion, we have found so far that encoding of these incentive cues, when you first see these cues, is associated with activation or engagement of subcortical regions that we know are involved in reward processing and vigilance and preparation, suggesting that it's the valence of the cue that is important, or the emotional quality of the cue. But yet the delay period is really associated with those networks that are involved in sort of self-reflection and sort of quiet rest. Upcoming analyses are to link our findings with behavior, to link with computational psychiatry. The lab collaborates with John Murray, and as I alluded to earlier, we specifically have picked spatial working memory tasks because of the long literature in monkeys and the neuronal firing that has been recorded there, which would allow us to build biophysical models. Examine the contextual manipulation, which was discussed in the behavioral results, which we have not gotten to yet in the current fMRI results. And finally, return back to the idea of cross-diagnostic translation. We know that these are deficits that affect a variety of psychiatric illnesses, but we don't yet know how they differ or how they are similar across illnesses. So that's a key question for us, as well as across development. So I wanted to just say thank you. There's a lot of people to thank, but I want to thank study participants for obviously sitting through a lot of these fMRI studies as well as the behavioral studies. It ends up being quite a long task, so thank you very much. The Antichevich Lab and Alan Antichevich, who has been a wonderful and generous mentor, without whom I could not have done any of this, and I specifically went to him with certain training goals, all of which I think we are meeting or have met, and so I'm very grateful for that. Nicole, who is our lab manager and keeps us all organized, our excellent RAs, Charlie and Brendan, who help collect a lot of data and provide a lot of structure for the lab. Lisa, who is a wonderful graduate student, has helped me out a lot. Genevieve and Katrin, who are now Genevieve has also received her PhD, and Katrin is a postdoc, also key supports in the lab. Martina, and who was involved in the early phases of the task. Jen Fosfag, who is also a key member of the lab, and Grega, who helps maintain a lot of our analyses. Vinod Strahari and the STEP Clinic for helping to recruit patients for these studies, for which we desperately need and could not have done alone. The Department of Psychiatry, for which I've really enjoyed my last 4 years here immensely, and the Neuroscience Research Training Program, which has been a huge, huge, huge part of my experience here. And thank you particularly to Dr. Mallison and Dr. Pittenger for organizing everything and being very supportive. And also the Psychiatry Training Program, Dr. Rohrbach, Dr. Ross, Dr. Zahari, Dr. Diaz, thank you very, very much. I've enjoyed my time here immensely. I'll be transitioning to the Child Study Center soon, so thank you there as well. The CNRU, which has been my clinical home for the last year, and prior to that as well. The MRC, where all these scans were run, and the support there, including Terry, Karen, and Hetty. And the Yale Center for Research Computing, which hosts our supercomputers, which I'm often on late at night. And the Detry Fellowship Award, which was a huge help in paying for all these scans, and without which I don't think there would have been as clear of a direction to create a project and move forward, but it gave us the structure and the means to create a project and really execute it. And finally, the family of Seymour L. Lustman as well. Thank you very much for providing this opportunity to the residents. It's very much appreciated. Thank you. And thank you to my family. My parents, thank you for your support, and thank you for your care. I didn't mean to forget about you. And my son, Leo, who's just wonderful and inspiring. Thank you. Thank you.
It's a full schedule this morning, and so we'll try to get through the presentations. If there's any time at the end, we'll try and open it up for questions. Now I'd like to yield the floor to Chris Van Dyke, who will introduce our next awardee.
Well, thank you, Bob. Good morning. So at the Alzheimer's Disease Research Unit, we don't have much opportunity to work with residents. Based on our experience with Adam, we'd love to have more, if any of you are interested. Adam first approached us 3 years ago for his case rotation at the end of his PG2 year. That segued into the PG3 and 4 years, where he was a fellow working with us under the R25 grant and the NRTP. And that in turn segued into the PG5 Geriatric Psychiatry Fellowship, where he's also worked a lot with ADRU, continuing his research. Now, as you'll see, Adam's research really focuses on PET imaging, amyloid PET imaging, which he'll present this morning, but also receptor imaging with mGlu-R5 receptors, synaptic imaging with SV2A in Alzheimer's disease. And his research skills really will speak for themselves in the paper that he's going to present. But I also want to highlight that Adam is really a wonderful clinician, a great communicator with patients and their families. He's also a tireless teacher. And in particular, during his time with us, he's led a work group for our very upwardly mobile staff, most of whom are here and are graduate school bound in one way or another. So Adam has led a research methods group with them, on his own time, and very much appreciated. But all around, we've become so dependent on Adam, we really have not been able to let him go. We've coerced him into accepting a faculty job, July 1. So we have many, many years to come, we hope. Adam also, if I may say, received a very, very good score in his K Award, knock on wood. We think a very fundable score, and so we look forward to years to come. Adam.
Can also thank Young Son's family. All right. Oops, that's not it. All right. Whoops. Ooh. Sorry, hold on 1 second. Okay. So, good morning. Thanks a lot, Chris. That was very, very nice. And it didn't take much coercion to get me to stay. It's really an honor to receive this award and to have the chance to present our work. I want to thank the Lustman family and the Lustman Foundation first, and also the selection committee for giving me this opportunity. I'm going to tell you about our work on brain amyloid imaging in healthy individuals at risk for Alzheimer's disease. And I've been working with Chris Van Dyke in the ADRU for, like, as he said, about the last 3 years, and it's really been an outstanding experience, and so I'm very excited to share this with you today. And so to start out, I just wanted to give a brief review of Alzheimer's disease pathology because it's important to understanding why we might care about the presence of beta amyloid even in healthy individuals. So clinically, we observe Alzheimer's disease as a progressive decline in cognition, and typically what we see first is decline in memory. And then often there are neuropsychiatric symptoms and ultimately functional decline. And Alzheimer's disease is associated with aberrant processing of amyloid precursor protein to form amyloid beta. And that's what I'm showing you in the top image here. And one of the leading hypotheses is that aggregation of amyloid beta occurs and has various effects, leading to ultimately to synapse loss, neurodegeneration, and also to accumulation of hyperphosphorylated tau. And the pathological hallmarks of Alzheimer's disease are shown in the bottom two panels. On the left side, we see accumulation of amyloid beta plaques. And then on the right side, you see neurofibrillary tangles, which are made up of hyperphosphorylated tau. So I wanted to transition to next introducing you to the concept of preclinical Alzheimer's disease, which is, I think, something that's less thought about. And also to discuss the relevance of identifying individuals that are in that preclinical stage. Oh, okay, got a pointer there. And so it's this phase here that I'm talking about along the x-axis, the preclinical part. So preclinical Alzheimer's disease implies that there's a point where the pathological process of Alzheimer's disease is occurring, but there are no clinical symptoms yet. And so you can probably relate this to other diseases like cardiovascular disease or diabetes, where it's a bit more apparent there that the disease starts far before any of the end-stage manifestations occur. And ultimately, people will progress from this preclinical stage to a stage of mild cognitive impairment, which is as we move to the right along the x-axis, and then ultimately to a stage of dementia where they're also experiencing impairment in functional abilities. And the presence of various biomarkers at different stages, do seem to support this staged model. And so on this graph, each of these curves represents a separate biomarker that might emerge at a different clinical stage. So going from left to right, in red, first is the accumulation of amyloid beta, which has been shown to be present even before symptoms exist. And then later on, we get markers of synaptic dysfunction, neuronal injury, brain structural changes on MRI, ultimately cognitive changes, and then functional changes. And there have been various investigations into the associations that exist between the presence of brain amyloid in cognitively normal individuals is what I'm really focusing on. And then markers of subtle cognitive decline, but also of neurodegeneration. So this is one example from a Harvard group where they found an association between amyloid beta positivity on PET scans cognitively normal older individuals. Remember a short story, and then those with positive amyloid scans, which is shown in the dark blue bars, scored significantly worse, both after when asked to immediately recall the story, when asked to recall the story after a 30-minute delay. And then this is just another example of some findings in preclinical that was collaboration at WashU and Harvard. And here they did an exploratory analysis of cortical thickness patterns and the associations with brain amyloid beta. And so the maps that I'm showing you here, the hotspots are regions that are typically associated with decreased cortical thickness in mild Alzheimer's dementia. So these are actually this is actually a mild Alzheimer's dementia brain compared to healthy control subjects. And what they found in this study was that there was a similar pattern in cognitively normal individuals that had positive amyloid beta PET scans. And their primary outcome was this overall pattern in a voxel-based method, which wasn't significant, but they did see that on secondary analyses, subregions showed significant associations. In particular, they drew focus to the temporal pole and medial temporal regions, which are commonly affected early. So there's also evidence of preclinical disease changes with functional MRI. That's what I'm showing you here. And so this is yet another study where functional connectivity between regions of the default mode network are reduced in cognitively normal individuals that have brain amyloid present. And so on the left is a T-score map showing decreases in connectivity to a seed region that's in the posterior cingulate cortex. So everything is compared to that little blue dot that you see. And on the right is it's showing again these correlations, but the correlations that exist between nodes of the default mode network. And really, in every one of these interactions, you see that the PIB negative subjects, which are the amyloid negative subjects, had higher amounts of connectivity between these brain regions. So in summary, there's evidence for a preclinical Alzheimer's disease process in older individuals, and this is based on outcomes from various types of studies that include memory performance outcomes, structural MRI outcomes, and also functional MRI outcomes. So then the question becomes, why do we clinically care about preclinical Alzheimer's disease if it isn't causing any symptoms yet? And I probably alluded to this already, but it's been proposed that intervention early during the preclinical state may be the best chance at preventing subsequent synaptic dysfunction and neuronal loss. But it's unclear how early in life these changes can be detected, so it's not totally clear how early you should be looking yet. And so one clue to understand that is that it's really in people loaded for Alzheimer's disease risk that we'd expect to find early accumulation of amyloid prior to the presence of symptoms. And the three most significant risk factors really are age, family history, and then ApoE genotype. And the graph on the left that I'm showing you shows that Alzheimer's disease risk increases with age, which is something that's commonly known, but also that risk is further increased in individuals who have a first-degree relative with Alzheimer's disease. So the line on the top is those with a first-degree relative, and then the lower line are those that don't have a family history. And then the table on the right is an example of the effect that ApoE has on risk. And so in the top row, and actually all of the subjects that went into making that table also have a family history, so the risk here is a little bit higher than you might see with just ApoE4 alone. But the AD frequency increases as the copy number of ApoE4 alleles increases. And also the age of onset actually seems to decrease. So these are major risk factors. So our goal was to study biomarkers of Alzheimer's disease, but in a group of individuals that was both enriched for genetic risk of disease, and this was done in order to look for evidence of a preclinical stage, but we also wanted to do this at ages younger than previously described. And so to do this, 3 groups of middle-aged participants who had a first-degree relative with Alzheimer's disease and variable genetic risk based on ApoE genotype were matched by age and also in sex. So there were 15 participants in each of the 3 groups, one group having ApoE4 homozygotes, the other 15 were heterozygotes for E3, E4, and the last group were homozygotes for E3, so they're the lowest risk group. But overall, all of them have elevated risk because they all have first-degree relatives. And all of these subjects underwent a screening visit, both to ensure that they could participate and to assure that they're cognitively normal. They had neuropsychological testing battery that was quite extensive. They had structural MRIs and also amyloid imaging that was done with carbon-11 labeled Pittsburgh compound B and PET. And when we group by ApoE genotype, there were no differences in age, sex, or education between these groups, which was the goal. And also, if you look at the other measures at baseline or at screening, I should say, of mini-mental status exam, full-scale IQ or estimated premorbid IQ, which is here with the WAIS-3 and the RAT-3. And then if you look at geriatric depression, there's no deficits within any groups of any of these participants, but there's also no difference between the groups. So other than their ApoE genotype, these groups are very similar is the point. So brain fibrillary amyloid was quantified using PET imaging with Pittsburgh compound B and kinetic modeling. And in this figure, I'm showing you examples of PET images, both for high amyloid burden, which is on the left-hand side, and then there's an individual subjects with low amyloid burden on the right-hand side. And there are two, and so basically the yellows and reds are the highest amyloid regions and the blues are the lowest regions. And there are sort of 2 additional points I'd like to make. The first is that our primary outcome for this study was a composite cortical amyloid burden value. So we used 5 cortical regions that commonly accumulate amyloid in Alzheimer's disease for that outcome. And the second is that we used a technique called partial volume correction. It allows us to recover signal that's lost due to the relatively low resolution of PET scans compared to MRI. And there's potential for greater variability in atrophy between subjects because we actually are expecting that some of these subjects are at risk of atrophy. And so this becomes even more important correction here, which is why we used it. And you can actually subtly appreciate the difference. This is an image before partial volume correction, and you might be able to tell that the signal intensifies in areas that are positive after the partial volume correction. So we hypothesized that amyloid burden would increase with increasing genetic risk, and that's exactly what's seen when the different ApoE genotype groups are compared. Mean cortical amyloid is shown on the y-axis here, and the 3-3 group, which is the red bar, has least amount of amyloid. The 4-4 group has significantly more, and then the 3-4 heterozygotes have a much larger variability but intermediate amounts of cortical amyloid. And in this figure, I've arranged the subjects in order of increasing amyloid burden just to put their relative amyloid burden into perspective, a little bit more of a clinical perspective maybe. And various groups have used a dichotomous amyloid binding cutoff instead of a continuous one like we have here. And when those groups have utilized a cutoff, usually a mean cortical binding of somewhere around 0.2 would be similar to what they use. So you can see that a lot of our subjects would meet those positivity criteria. And based on the preclinical Alzheimer's disease model, we might expect to see changes in gray matter volume even in this relatively young group. And in fact, increased amyloid burden was associated with lower gray matter fraction. And so gray matter fraction is on the y-axis here, and you can see that it decreases in subjects that have higher amyloid burden. And because memory is typically the first cognitive domain affected in Alzheimer's disease, we wondered if there might be also an early effect on episodic memory in our cohort. Not necessarily a deficit, but just a relative decline compared, or a relative lower score compared to those that are amyloid negative. And the memory performance score here is a composite Z-score made up of both a paragraph and word list recall score. And despite the association of amyloid beta with both the genetic risk, the ApoE genotype, or the gray matter fraction, there was no significant association with memory performance. And I'd like to just take a moment to summarize our findings and put them into perspective again. So, first we found that genetic risk is associated with amyloid burden, even in cognitively normal individuals, and the cortical amyloid is inversely associated with gray matter fraction. But not cognitive measures, so those didn't seem to be affected. And this does support, this is really evidence that supports a preclinical disease stage even at these relatively young ages in a high-risk group. So I'll take you back to this same figure that I've shown a few times. And again, if you look in the preclinical stage, you see early amyloid beta accumulation. And although we didn't measure these markers of synaptic dysfunction, there is the possibility that you could have brain structural changes early on before there are symptoms, and we believe that's what we're seeing here. So for this particular work, our hope is to continue by studying an even younger cohort of subjects and also broaden the search for relevant biomarkers, such as one example is something like a tau PET ligand, which we're able to do now. And this is an example from a paper of the distribution of tau binding in a subject who has Alzheimer's disease. And so you can see the middle figure is the tau PET imaging, and it's very similar to the post-mortem staining of a brain of someone with Alzheimer's disease that's all the way to the right. And this is very different than the amyloid accumulation that we see, which is the image all the way to the left. It's a different pattern. In addition, there's great interest in prevention studies, and there are currently 3 ongoing preclinical disease prevention studies, and we're a site for those studies. And the interventions are, these are exciting studies, and the interventions are very interesting. There's a monoclonal antibody that's active against soluble amyloid beta. There's a BACE inhibitor, which is one of the APP, the amyloid precursor protein cleavage enzyme, one of the enzymes that cleaves amyloid precursor protein and makes beta amyloid. So there's an inhibitor of that. And then there's also an active vaccine trial. So those are all very exciting studies that our research unit is a part of. And Chris mentioned that one of my primary interests is the molecular imaging that we do in collaboration with the Yale PET Center. And I'm not going to describe these images to you, but I just wanted to show them as an example of other things that we're doing. I'm very thankful to Rich Carson and the staff of the PET Center, and Rich has agreed to be a co-mentor to me as well. And the PET Center and Rich are longtime collaborators of Dr. Van Dyke, and they're really essential to the efforts that we make. So these are preliminary data from 2 exciting projects where we're investigating both synaptic density, as Chris mentioned, and then also mGluR5 density changes that occur due to Alzheimer's disease. I also have a lot of people to thank. First, the co-authors of and collaborators of the work that I just described to you, and they're all listed. Again, I'd like to thank the Lustman family and the foundation for this opportunity. It's been really a pleasure. And I'm lucky to have trained in an environment that's really supported this work. And so I'd like to thank the Yale Psychiatry Residency Program, the Neuroscience Research Training Program, and also the Geriatric Psychiatry Fellowship here at Yale. In particular, I also wanted to thank Drs. Mallison and Pittenger for their support and effort in the NRTP. It really provided me an opportunity to start out my research career by integrating it with my residency, and it's really been a huge motivator. And just to sort of put into perspective like how that fits into the department culture, something that I will always remember is when I came to my interview and our group was meeting with John Crystal, and he said a lot of things, but one of the things that I remember is he said, "There's no substitute for time to think." And I could tell that he had thought really hard about that comment. And that statement made a really big impact on me. And I think it's one of the things I thought about as I decided what to do in my training. And I'm really grateful for the time I've had to think about approaching complex clinical and research questions. So I would agree, there seems to be no substitute for that time. I want to thank also my coworkers at the ADRU, and they're like taking up several rows. We chronically can't seem to take a new picture, so there's also, but I've worked with everyone in this picture too. They've helped me find my way over the last 3 years. There's a lot of work going on in our research unit, and I still need to ask for help very often. Our work is really a tremendous collaborative effort, and all of our staff and faculty are so caring and smart and really highly skilled. I wanted to thank Chris as well. Chris is the Yale Department of Psychiatry Alzheimer's Research Unit Director, and he's working on both a national and global level to, with the effort to effectively cure Alzheimer's disease. And he's created a world-class facility for conducting cognitive disorders research here. So it's been amazing to be a part of it. And I really feel like I kind of stumbled onto Chris because I actually met him sort of by chance when I was at a seminar during my intern year. My wife was a geriatric medicine fellow, and I actually went to the seminar to eat lunch with her mostly. And so Chris gave a talk about Alzheimer's disease research. I was really inspired by it, and sought out his mentorship afterward. And he's been a kind, patient, and really supportive mentor. I feel that he's helped me grow in my independence, and also has helped me stay focused, though, which has been important. And so I'm really grateful to his mentorship, because good mentorship is just really a very important thing to have. Finally, I want to thank my family. Some of them are here today as well, and I'm really excited to share this experience with them. And I put in an extra picture of my kids because it was a really cute picture. And I'm really trying to encourage my kids to they're early interested in neuroscience, and so we're also going to make a pitch to Dave Ross for some NNCI modules that they've been developing. And this might be fake. So they've so far worked out two. The first module is called Where's Your Brain? It has a really quick teaching video that we've developed.
Where's your brain?
That's right. So it's in his head. So he nailed it. And then the second one, we're thinking of maybe like neuroscience poster design or something about neuroscience art. And so to start this out, I asked my daughter to critique my poster, and she just said, especially the image. I was trying to decide which image to use. She just said, "It's beautiful." So I knew that it was ready for the meeting. And all right. So thank you again for your time. It's really been a pleasure, and I'm happy to answer any. Well, actually, I'm not happy to answer questions till later. Yeah. All right.
So lastly, but not least, I'll introduce Jerry Santacora. For people who don't know, Jerry is one of the names outside on the plaque. He is a former Lustman awardee as well, and I'll leave it to you to look. I won't rat Jerry out on the year.
Thanks,
Anyway,
Bob.
And actually, should just note that he'll be introducing Sam Wilkinson, who's a second-time Lustman awardee today. Yeah.
Thanks. So it's really my honor to get a chance to introduce Sam. So Sam actually came about 3 years ago to the Depression Research Program with a little bit different than most of the other researchers that have come over. Pretty clear directive that he wasn't just interested in doing research per se, but Sam really had a pretty clear goal that he wanted to do work that was going to be directly and have impact in the near future in improving clinical care, which is a little different for some of us. But just to put it, I think if I double click, will I get this? Let's see if I can quickly, Oh no, how do I get this full screen? But there we go. So most of you, it's not giving me full screen here. Oh, there we go. Let me back up. So most of you are well aware of James Brown being the hardest working man in show business, right? Well, I like to think of Sam as the hardest working man in psychiatry. Just to give you a very quick overview of Sam's productivity over the past 2 years, just to really give you some sense. He's had 7 first authored papers, original research papers in the past 2 years, 5 book chapters, reviews, 6 case reports, 3 grants in Narset, Patterson, and Nadetri, all within the past years, and 6 travel awards. So really incredibly productive. But the important thing is this is all while he was having a really heavy clinical caseload. He being the chief resident and then the fellow at the Interventional Psychiatry Service, where Robert Ostroff now says that Sam has probably treated more people with ECT than anybody else but him in New Haven. So he really has an incredible clinical experience from that side. He's been the research fellow at the Yale Depression Research Program for 3 years. That really has a very heavy clinical demand to it. And besides that, being a research fellow with Morris's Intervention Psychiatry and Disabilities Program, which required a lot of educational work for Sam, especially really getting a very strong background in biostatistics. Oh, and did I forget to mention that while he was doing all this work, he was helping his wife Sarah to raise 4 children under the age of 8 with hungry little bellies that required a lot of moonlighting. So Sam is really, I mean, it's really hard to keep up with him with the amount of his productivity. But more specifically about what his work is, I think what he's going to present today captures a lot of the 2 things that really drives him. One is improving clinical care more in the real time, and also showing his hard work. So a lot of you may look and say, oh, this is a meta-analysis. So he probably read some papers, did some stats, and that was it. But I don't think you realize that this type of work, especially this patient-level meta-analysis, required an incredible amount of work, both in terms of doing some novel statistics that he had to help Michael Block and others here at Yale in terms of the statistics. But he also had, you could see to get the data from all these other places that he needed to acquire data, including the National Institute of Mental Health. You can imagine the bureaucratic process that he had to go through and really work through to get this individual patient data from them. But then also getting data out of the Czech Republic and from China. This was not just simple, read the papers, do a meta-analysis. This really required a lot of work, working very closely and being very patient for all this to occur. So with that, I'd like to introduce Sam. I think we're incredibly lucky, and while he's walking up here, I'll say I think this also really speaks to the potential and the great benefit we have from programs like Bob's R25 that allows somebody like Sam to really jump into research without having an incredibly strong background. All right, thanks. So.
Thank you, Jerry. I appreciate that kind introduction. It's funny, I don't remember that photo in my my photo album. I must have contacted my mother. And so before I start, there we go. This is okay. I want to say thanks to my mentors and most notably Jerry. A couple years ago, Alan Lewis showed this little comic strip of this is often how we view ourselves as trainees and students, and sometimes our mentors see us in a different way. But I'm grateful for Jerry, who sees me more as the picture on the left, and that's all I'm going to say about that. So I just want to talk a little bit about the background and the problem of suicide, and then also just very briefly about ketamine, which many people in the room are familiar with, and then I'll talk about the study for which I've been fortunate to receive this award. So first off, to talk about suicide. Well, before jumping into suicide, this is from the National Institute of the National Heart, Lung, and Blood Institute, showing. I mean, this is an amazing victory in public health. Here is the trajectory of cardiovascular-related deaths up until about 1970, when people started to understand the pathophysiology of heart attacks and related problems, and we're able to intervene in meaningful ways, and you see that the rate just plummeted. And this only goes back to maybe 12 years ago, but 12 years ago there was something like a 1.1 million fewer deaths because of these these advances in biomedical research and interventions. And I'm sure today it would be even a greater difference between what would have been the projected death rate and the actual death rate. Unfortunately, in psychiatry, the suicide rate has been gradually but consistently going up. This just goes back 11 years, but this is stratified by gender, and you'll see, from the just before 2000. Again, a gradual but steady increase in the suicide rate. And here, this is data from the CDC. It's maybe a little hard to read, but the green panels are suicide. This lists the top 10 causes of death by age group. And from age 10 to 34, the second leading cause of death is suicide. And then overall, at the end, the total all-cause mortality for all age groups is suicide is number 10 as the top 10 cause of death. So, I mean, this really is a public health problem, and one that we haven't been able to address. So, onto this story is the unfolding narrative of ketamine that I'm going to share just briefly. So many of you have probably read in the lay press of a number of kind of sensational headlines touting ketamine as a miracle cure, as rapid-acting antidepressant, and I mean, I think there's great cause for excitement. A number of people, practitioners really, have started to provide this what we call off-label for psychiatric disorders. It's not FDA approved for any psychiatric disorder. It's FDA approved as an anesthetic agent. But this is an advertisement from one of the first quote ketamine clinics that opened in New York, and we've actually done a little bit of work to get a sense of this growing trend. We did a survey in which we looked at a fair number of people who are advertising on the web that they treat depression with ketamine, depression and other similar disorders. And while the absolute numbers are somewhat low still, the trend is kind of unmistakable. So again, many in the audience are familiar with ketamine, but just as a brief background, it was first discovered just before 2000, actually by some people are in the room, at the West Haven VA, that ketamine can induce a rapid antidepressant effect in people with depression. This top panel is the HAM-D, which is a depression rating scale. And what you'll see is the group that is exposed to ketamine within, again, it's hard to see, I apologize about the resolution, but within 4 hours of being exposed, there was a clear separation between those who were exposed to ketamine and those who were exposed to placebo. And I think, I obviously wasn't involved in research at the time, but I imagine it was difficult to conceive of something acting so fast and not in the usual, take this pill for 2-3 weeks and we'll see if you're doing any better. But within a matter of hours, people reported feeling better. And these two bottom panels are the quote high or psychotic effects that people experience when they're undergoing this. It's usually a 40 or so minute infusion of intravenous ketamine. And what you can see here is that these symptoms kind of subside about 2 hours after the beginning of the infusion and are really kind of temporally disconnected from the antidepressant effect. This was first replicated by a group at NIH that was led by Dennis Charney, showing a similar type of pattern. So in that very first paper, it was noted that that suicidality or suicidal ideation was one of the symptoms that there was a significant effect of ketamine on. And since then, I think there have been a number of people interested in this effect of ketamine on suicidal ideation for a couple reasons. One is that it's rapid acting, and because of that, it may be a therapeutic that could avert hospitalization. You can imagine people presenting to an emergency room with significant suicidal ideation and in need of hospitalization that could be treated within a reasonable amount of time and could get much better, and you could avoid a hospitalization. There has been so far one published paper. There's going to be one or two more coming out, but this is the first published paper that I know of where the investigators recruited specifically from people who are at risk, thought to be at risk of suicide, and randomized them to, in this case, they used midazolam as the control arm to improve the blinding. And this study was done by James Murrow and his colleagues at Mount Sinai. I think there was a signal here, but they unfortunately failed to meet their pre-specified primary outcome. I don't think it was because the drug doesn't work, but because, as you see here, the sample sizes were relatively small. There were only 12 people in each arm. One of the limitations thus far in the ketamine literature is that because there's no patent protection, there are a number of academic trials, but they're generally of small sample size. And so we had this idea to try and get people to come together, because the protocols that are used are very, very similar. It's the same dose in almost all the studies, and a very similar time course. So the hardest part was, the systematic search was easy. We found what we think were all the single-dose ketamine studies that have been done since 2000. The hardest part was getting everyone to come together, as Dr. Sanacora showed the list of co-authors that generously contributed their data. But once we did, we were able to get the data, thinking that our main question was the effect of ketamine on suicidal ideation. We excluded people who did not have at least some baseline level of suicidal ideation. And then I can go on the statistics more about this in the questions, but we did what's called a one-stage individual participant data meta-analysis. Basically, we used what's called a mixed effects model, where you account for variation between subjects, but also between studies. So subjects are nested within studies, and then there are fixed effects within studies, within the same person over time. So I'm just going to, in the interest of time, I'm going to skip ahead. These are just showing what our baseline measures of suicidal ideation, what we considered suicidal ideation. We just used a precedent in the literature. So we found 10 studies that we could include, and this gave us a total sample of almost 300 participants who were either assigned to placebo, a control group, or ketamine. And then after we applied our criteria of only including people who had some measure of baseline suicidal ideation, this brought the sample down to 167. You'll notice here this was meant to be transdiagnostic, although most of the studies were specifically in mood disorders. So MDD stands for major depressive disorder, and then BP is bipolar. There were some that were mixed or PTSD, so non-mood disorders, but overall the large majority was either unipolar depression, as I think 77% were of the patients were unipolar depressed, and then probably something like 18% were bipolar. So we ran the model, and we got, I think, something what we were expecting is that there was a fairly large effect on treatment by time interaction, meaning that the slopes are different. So you'll see here the people who got ketamine, there was a rapid reduction in suicidal ideation over the first day, the first 24 hours. And that pretty much stayed flat up to 1 week, which is when these studies looked out until. So again, there's one dose of IV, either ketamine or the control, and the rapid reduction, and it stays fairly flat. These error bars, by the way, are 95% confidence intervals. And then there was a somewhat gradual reduction in the control arm, which I think speaks to the somewhat fleeting nature of suicidal ideation. So these people tended to get better as well, but the people who received ketamine got much better. I should mention here, just for methodological purposes, we combined, there were two different scales that were used across the studies. One is called the Hamilton Depression Scale, and the other is called the MADRS, or the Montgomery-Asperger Depression Scale. We combined these using a method, and because there wasn't much precedent for using that method to combine, we looked at these scales individually. So this is the people who received only the MADRS, and this brings our numbers down a little bit, but you get basically the same pattern and shape. And this just gives you some sense of what these numbers on the y-axis mean in terms of how the level of suicidal ideation that this represents. And again, so we also looked at the Hamilton Depression Scale individually, and we got a somewhat similar pattern. This brought our numbers down quite a bit because only about half of these people had Hamilton scales. But you do get a somewhat similar pattern. So these are what we refer to as clinician-reported outcomes. We also looked at patient-reported outcomes. So patients are often given their scale, a scale to fill out on their own and self-report their level of suicidal ideation. And again, we get a very similar pattern. That there's a rapid reduction in suicidal ideation over the first 24 hours. That again stays somewhat flat over the course following exposure. And then we looked at the individual self-reported scales. This one is called the Quick Inventory of Depressive Symptoms. Again, this brought our numbers down somewhat, and so we lose a little power. But this scale showed the same shape. We didn't quite get the same result with what's called the Beck Depression Scale, and we're not exactly sure exactly what's going on here, except this had the smallest number of people that undertook this scale. We looked at what you call dichotomous outcomes, so the proportion of people after at each day who were free of suicidal ideation, and so at baseline, I don't have it listed here because no one is free of suicidal ideation. That again is kind of inclusion criteria to be in the analysis portion of the meta-analysis. But you'll see here that just 1 day after, 55% of people who get ketamine are free of suicidal ideation. This translates, the absolute difference in kind of chance of being free of suicidal ideation translates into what's called a number needed to treat of somewhere around 3 to 5. So that's fairly good, especially in psychiatry. And then this is just the same thing looking at self-reported outcomes, people being free of suicidal ideation. And then I think finally we looked at what's called effect size. So effect size is a measure of your group difference divided by a pooled standard deviation. And this is kind of the standard here. A small effect size is 0.2, medium is 0.5, and a large is 0.8. If you have an effect size of 1, that means you move your whole group over, your group over 1 standard deviation. And the effect sizes here were fairly impressive in the medium to large range for all the time points post-dose. And then there is this interest in the literature, in the field as to whether there's an independent effect of ketamine on suicidal ideation that is, again, independent of its effects on mood symptoms generally. And so probably the best way to answer this question is to do a study looking at a number of different diagnoses in people who have suicidal ideation. We we tried to do that, but there weren't that many that were not, did not have some sort of mood disorder. So we looked at it statistically, covariating for change in depression the symptoms over time. And the treatment by time interaction remained significant. It was definitely attenuated, but this was I think something that was exciting for us to find. So there are a number of limitations to this, and first off is that suicidal ideation is not the same as suicide or suicide attempts in any way. With the exception of one of the studies, most clinical trials exclude people who are thought to be in imminent risk of suicide, so that's a big limitation. It is very exciting to note that there are several studies either just completed or underway that are specifically recruiting people who are thought to be at risk of suicide and in need of a hospitalization, which are, those are somewhat challenging and challenging studies to undertake, but I think they're greatly needed given the problem of suicide that I showed in the beginning of my remarks. And then another limitation, this is secondary analysis, I realize that, but I think there was some benefit to doing this analysis. There are measures of suicidal ideation were just a single item, and then finally there's a problem of blinding, but that's kind of prevalent throughout looking at ketamine studies. But nonetheless, we did have some positive results. So that's basically it. I do want to thank many people who have helped me in my brief career so far, most notably Drs. Mallison and Pittenger in the NRTP, and Dr. Morse Bell, who's the director of my fellowship. This week I'm just finalizing my first federal grant application, and the minutia that is required for these federal ones is quite substantial, and these people write these training grants, and it's really to benefit people like myself who are trying to become investigators. So this week I've been especially appreciative of what you guys do for us. So and then people involved in this particular study, obviously I want to thank the Lustman family for their generosity, and then Dr. Shanna Corrigan and Michael Block, who helped out with the statistics. Some of our other collaborators are pictured here, who generously donated or shared their data. And then people in the depression clinic, Beth Cooper is an amazing research assistant, Jane Massoud, and Michael Kane, who helped also with the biostatistics. So again, these are some of the people who made this work possible. And then I just want to share the people who made this work necessary, which is these people. And with that, I think we can take questions. So.